Okay, in this video we will talk about tree. A tree is a special kind of graph which contains a special node called root. So this is an example tree. Now this is an example tree of what we call as a general tree. So before we look at the different exercises which we can do on tree, let's look at the terminology in tree. So the first terminology is this node A, which is called as root. Now root is a special node in a tree which does not contain any parent but only children. And we have now B and C. These are the children of parent A. Now we can see B and C are the children of A. So B and C are called as siblings. Similarly, D, E and F are children of B. So these three are also siblings. And now we have G and H. They do not have any child nodes, so we will call them as leaf nodes. These are the some of the terminology related to tree. We have another concept called height of a tree. To know the height of the tree, we will first try to find out how many levels this tree is. So level starts from level 0. So the root will be at the level 0. The next generation is level 1. The next generation is level 2. And the last generation here is in level 3. So height of the tree is number of levels plus 1. So height of the tree here is 4. Another concept in tree is forest. Forest is nothing but group of trees. So if we have something in this manner, then we can say this tree as a group is a forest. Now we will look at a special kind of a tree known as binary tree. Binary tree is a tree where you'll have root and it can have at most 2 children, not more than 2. And each child either will be a left child or a right child. You won't have anything as middle child. So I can have like this, or maybe only with one child. This is an example of a binary tree. Binary tree is important in data structures because it is easier to implement binary tree than general tree. So since binary tree is easier to implement in system, we usually need to convert a general tree into a binary tree. So we'll try to see how to convert a general tree into binary tree. There are basically 3 steps to convert a general tree into binary tree. The step 1 is you need to insert the edges connecting siblings from left to right at the same level. Second step is erase all edges of a parent to its children except to its leftmost offspring. And the third step is rotate the obtained diagram tree 45 degrees to mark clearly left and right subtree. Let's try to understand these 3 steps using an example. Let us take an example of a binary tree over here. Now I want to convert this binary tree into a general tree. Step 1 says we need to add edges to all the siblings. Here B, C and D are siblings. So you now add edges between B, C and D. Now here B has only one child, so no issue. Now when it comes to C we have F and G, so connect F and G. D contains H, I, J, so these are 3 siblings, connect them. And when it comes to G, it contains 2 children, so K and L are siblings. So this is step 1 where we connect the siblings with NH. This is the step 1. Once the step 1 is over, the second step says you need to remove the edges of the child nodes to its parents and you leaving only the leftmost child. So here when you look at A, B, C and D, here B is the leftmost child of A, C and D are the other children. So we need to remove the edges from A to D and A to C. Only A to B edge will be there. Similarly, when it comes to C to F and C to G, C to F is leftmost child, we will leave it like that, but remove the edge between C to G. Similarly, from D to H we will keep it, whereas D to I would be removed, D to J would be removed. In the same case, G to K will be there, G to L will be removed. So finally, we will have like this: A with B, C, D, E, F, G, K, L, H, I, J. This is how we will have after your step 2. The step 3 says you need to rotate the diagram 45 degrees. The simple way to do this is keep A the root. The leftmost child will be in the left side and the siblings of B, which is C and D, will become the right child of B. So C is a sibling of B, so it becomes the right child. D is a sibling of C, it becomes C's right child. B to it, since it's a left, it will remain in the left side. Now again C to F, F, F to G, G comes at right. G to K, it's left, so it remains as left, whereas K to L, like this. Similarly, now D, the leftmost child, H would be left, whereas I would come at right, and J, since it's sibling, it will come to J. So this is how eventually a general tree can be converted into a binary tree. You can see the binary tree. When we said binary tree can contain at most two children. So A contains one child. It contains two children, one child, like this. So this is how you can convert a general tree into a binary tree. Thank you.